So actually, if you consider DC motor or stepper motor, so in the DC motor, you do not have control on the angle, whereas the stepper motor we can have precise control on angle which it rotates. For example, you have a motor and pole or like wheel connected to it. So as soon as you connect a power supply to the DC motor, it starts rotating. But whereas in the stepper motor, you can limit where it has to rotate, like 45 degrees, 30 degrees. That is the major advantage of stepper motor. That's where, especially in robotics application, they use stepper motor. I mean, we do use a DC motor, especially for driving vehicles in terms of robotics. But whereas like controlled arm or if we want to have precise turning and all, then we use the stepper motor. So usually the resolution in the sense how much we can turn this angle, how much angle we can turn, minimum angle we can turn, right? So it's like per step, one step equals to what is the angle is referred by resolution. So example, if someone says like we have a 200 step motor, then resolution per step is, you know, like total rotation what it can have is 360 degrees. So 200 by 200, every step can lead to 1.8 degrees. So coming to the working principle, uh, we have like, for example, like we have like we consider with the four-step stepper motor. So we will have electric poles like this, for instance, four poles connected to. And also we will have magnet generally south pole and so. For instance, if I uh, like here everywhere, like we will be winded with the electric cables, electric wires, copper wires. So wherever I energize, so for example, if I energize this step, so this will become north and this will become south. You know, the south pole will attract towards north. So here, this basically the pole is going to turn towards that step. So basically, like for each uh, angle, we will have a bit corresponding to it, a bit associated with it. So whenever, like if I program like this, I don't energize this, I don't energize this, I don't energize, if I energize this, so this is going to turn towards that. So again, if I want to turn right, then I will energize this, I will turn this, right? So this way, actually, again, we can go for the anti-clockwise action. So from here, if I want to turn anti-clockwise, I'll energize this and I'll make all other. So this way, I can control the operation of the thermometer and the rotation of the thermometer. So in stepper motor also, we will have various types of stepper motor. One is basically permanent magnet stepper motor. Second one is variable reluctance stepper motor. So here in the permanent magnet stepper motor, the rotor, this one, this is called rotor. So that is built using permanent mode. So next is variable reluctance stepper motor. Here the rotors are built using soft iron. So final one, third one is hybrid stepper motor. Here combination of permanent and variable reluctance rotors are used. And based on the stepping mode, like how we uh, rotate this stepper motor, we have again various modes. One first mode we call it as full drive. So here in the full drive, what we are going to do is we are energizing two coils at a time. So here what happens, like for example north, and here we will actually uh, here we will make south and north. So two coils are energized at a time. So advantage of this is more torque, especially in case of industrial application. We go for the full drive application. And next is wave drive. It's a soft drive, only one coil I will energize it. It's a wave drive. And next is half drive. So here we actually drive half of the angle, even if we have step of 1.8 degree. So we basically drive half of the angle, but here we need to energize more coils such a way that it will align to the half position. That we call it as half drive. So with respect to like two-phase four-winding stepper motor, like let's see like how we can drive that stepper motor. So usually in this stepper motor, so here A, B, C, D, right? So this will be connected to your the base of this, right? So this here you will have one transistor and connected to ground, and base usually we connect to various pins of microcontroller like P0 dot 16. Here this we will connect to P0 dot 17, 18. Okay, so here this will be connected to LPC2148. So to get the full circuit, I'll share the full circuit of this. You can see this circuit, right? So here, mm, with LPC2148, like we have a stepper motor driver where we will see say that like what value we need to drive, the angle which we have to drive. So we will have like external stepper motor driver because whatever the signal if we directly send it, right? So to these signals. So here the LPC2148 is just capable of 3.3 volts. But what we want here, in order to drive this stepper motor, we want 12 volts. So this driver supports like from external voltage supply. So it supports 12 volts. So that's where like one of the IC which is available is ULN2803 is a stepper motor drive. So usually in ULN 2803, this A, B, C, D are there, right? We have to drive to the various voltages. Like if I want to have clockwise direction, I will drive like 1 0 0 0 0 1 0 0 0 0 0 0. Same way, if I want to drive anti-clockwise, the sequence will reverse. So I will go this. So this will drive anti-clockwise. Wherever, like whenever I want to have a full drive sequence. So as I said, opposite sides I have to make two drives at a time. Right? So this is actually wave drive. So whatever the sequence I have given, that is for the wave drive. If I want to go for the full drive, then 1001 or 110 this way, or I can have 0110 is done, right? So one more is 1100. This way I can have a wave drive.
Sir, I cannot hear anything now.
Yeah, I'm listening.
Okay,
So,
sorry, sir. I thought it was a network issue. So,
no. So next we have a program to write a embedded C program for driving a stepper motor clockwise direction for M step and anti-clockwise direction for N step. So if someone say it is like 200 teeth shaft, so we know that like 360 degree by 200, like every step will go for 1.8 degree. So as we know, uh, for like rotating clockwise direction, right? So first, like any C programming, with respect to LPC2148, first we need to declare the header first. Hash include LPC214x dot x. This includes the font size. Then in main, so as I said, like we have connected to 16, 17, 18, 19 of P0, right? So first I need to set IO direction. IO direction. Setting means I have to make OR operation, right? So OR, because see why I'm doing OR is basically if I directly set, if some other bits are already having some value, that also will get clear. So if I do OR operation, only whichever the bit I want to set the direction, only that bit will get affected. So as I said, like from 23 to 16, I have to operate. Yes. So 20, 16, 17, 18, 19, 20, 21, 22, 26. That is total 8 bits. So MSB wise, we have 32 bits. Out of that, 32 to 31, right? So 31, 30, 29, 28, 27, 26, 25, 24. That is 8 bits. That is 0. But I am affecting 23 to 20. That I have to make it high. So 111, that means F. So 19 to 16, that is also F. So then 15 to 8, that is 0. 7 to 0, that is 0. So the IO direction, what I have to write is 0 FF 0 0. 0 X, okay, 0 X, just not, yeah, FF. FF 0 0. And again, see, actually 16. So then next 8 bit and next 8 bit. So up to 0. So this I am setting IO direction. So it basically means I am making E0 dot 16 to 23 as output. Next, what I'll do, I'll make everything to the clear state. And then I will set the clockwise. I mean, first initially I'll go with the clockwise direction. Then I will go with the anti-clockwise direction. So here they have mentioned like M step clockwise and then anti-clockwise N step, right? So I have to define. So I'll define unsigned int number of, okay, number of steps clockwise. Let me define 100 steps, comma, number of steps a clock, that is anti-clockwise. That is also 100. So I'll rotate 100 anti-clockwise, 100 clockwise. So I'll run a do while loop. Do. So first I'll clear everything. So if you see, even though I'm using from 16 to 23, out of that 16 to 19, I'm using only 4 bits. So in that sense, I, O, 0, CLR, I'll clear everything. Which are the pins? 0x, out of this, out of this, uh, like MSB, this also I'm not using. Okay. So F followed by 5 zeros. IO clear. I'll do this. Then I have to do the one step right, right? Every time I have to go one step right. So when I say one step right, so the sequentially it will be, so in these two pins, in this pins, right? First, what I have to write? 19 I have to make high. 0, 0, 0, 1. Then I have to shift left, 0, 0, 1, 0. Then again left, 0, 1, 0, 0. Then 4, right? So on. So what I'll do, F0, then IO set, IO 0 set 0x 0 0 1 1 2 3 4. This is one rotation, one step. Then I'll give some delay of 10 milliseconds. Then if I have reached maximum, if number of clock sets equals to 0. Every time I compare this, I'll negate this. Okay? Negate by 1. If this condition satisfied, then I will just stop this because 100 steps is already done. Else, I will add one more. For one more step, it is not 1, 2 is left shifted by 1, right? So 2. Same way, we'll have 4 and 8. It's a wave drive, not full drive. It's a wave drive, what we are doing. So instead of 2, it will become 4 and 8. So this here, I said, as I mentioned, it is a do while loop. So this while loop, while 1. Same way, when you want to go for anti-clockwise, so here I'm not decrementing clock. I'll be decrement a clock, a clock, a clock, a clock. So here also, till it becomes 0, it keeps driving. Okay. So once everything is done, what I will do, I will clear everything so that your motor will stop. So it will rotate clockwise n number of steps, anti-clockwise n number of steps, then it will stop. Hope you understood the logic. Any doubt so far?
No, sir.